x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so today we're gonna talk about 30, 60, 90 right triangles and 45, 45, and 90 right triangles. This is special right triangles. It's gonna be a part 1 and a part 2. This is a recap of what we have been going through. So this is 45, 45, 90 right triangles. For 45, 45, 90 right triangles, these two angles are 45, which means the sides across them are going to be the same length. And then this other side, the hypotenuse is going to be when I take the x and multiply it by the square root of 2. So this is going to be x square root of 2. For 30, 60, 90 right triangles, we have the short leg. The short leg is across from the smallest angle. So the smallest angle is across from the smallest side. So this is called the short leg. We'll call that x. When the short leg is x, then we have this relationship with the hypotenuse. And this is the hypotenuse. And if I know the short leg is x, then the hypotenuse is 2 times as big, so that's going to be 2x. And then we have the long leg, which is across from a 60-degree angle. And this is the long leg. And the long leg is when I take the short leg times the square root of 3. So x times the square root of 3. And so we have all these formulas over here that are true. We're going to work a couple example problems. So this example problem here, this is 45 degrees. So if that's 45 degrees and this is 90, we know that this has to be 45 degrees. So two sides are the same. This is going to be 6. If this is 6 and that's one leg, then this leg also has to be 6. So this side is 6. And then if I want to find the hypotenuse, I take the leg times the square root of 2. So this is 6 square root of 2. If you use a Pythagorean theorem, you would end up with the same answer. Same idea here. If this is 8, that means that's 8. And this is 8 square root of 2. Over here, it's the same situation. So this is 3 square root of 2. But when I multiply this by the square root of 2, I get 3 square root of 2 times the square root of 2. And square root of 2 times square root of 2 is square root of 4, so that's 3 times the square root of 4. The square root of 4 is 2. So you end up with 3 times 2, which is 6. And that's the work that you should show for a question like that. Same idea here. This is 3 root of 6. So this is 3 square root of 6. This is 3 square root of 6 times the square root of 2, which is 3 times the square root of 12. Now the square root of 12, we want to break it down into a perfect square if we can, and we know that 12 has factors of 4 times 3. And the square root of 4 is 2, so that comes out. And so we have our 3, and then we pulled out this 2, and we're left with a 3 underneath. So that's going to be 6 square root of 3. And that's your final answer for that. Conversely, if we have a 45, 45, 90, here's the 45, here's the other 45. So this time they didn't give me a leg, they gave me the hypotenuse. So instead of multiplying this times the square root of 2 to get there, I have to do the opposite, the inverse. And so instead of multiplying by the square root of 2, I'm going to divide. So 6 square root of 2 divided by the square root of 2. The square root of 2's cancel, and I'm left with 6. So x is equal to 6, and y is also equal to 6. I have to do that again with 4 square root of 6. Again, they gave me the hypotenuse, and I'm looking for the 2 legs. So 4 square root of 6 divided by the square root of 2. Well, square root of 6 divided by square root of 2, since they're both square roots, I can just simplify that. It becomes 4 square root of 6 over 2, which is 4 square root of 3. And so y is 4 square root of 3, and x is 4 times the square root of